In this video, I'm going to give you an introduction to the Solidity programming language so that you can become a blockchain developer. And it doesn't matter if you're brand new to blockchain or if you're just learning to code. I'm going to teach you everything from scratch. I'm also going to show you how to do this directly inside your web browser so that you can get started quickly. You won't have to install any special software on your computer to get started. And the best part is, I'm going to show you the most updated version of Solidity because a lot has changed. So make sure you subscribe and click the like button down below so you can catch those videos when they come out. So before we get into all that, if you're new around here, hey, I'm Gregory from Dapp University, and on this channel, I teach you how to become a blockchain master. So if that's something that you're interested in, then head on over to dappuniversity.com/bootcamp. Solidity is the main programming language used for writing Ethereum smart contracts. It's object-oriented, and it looks a lot like other common programming languages such as C++, Python, and JavaScript. So if you're familiar with any of these languages already, then you're going to have a huge advantage learning Solidity. So it's statically typed as opposed to dynamically typed. It supports inheritance and also libraries. So don't worry if you don't understand what these things mean just yet. You're going to learn all those things inside this tutorial series. And let me quickly mention that we're going to use the latest major version of Solidity for the year 2020 in this tutorial. So we're going to focus on version 0.6. And that's one of the big benefits of this tutorial series is the blockchain landscape is constantly changing. Solidity is always updating new versions. And I'm going to educate you in all those changes inside this video. This is a website that allows you to write Ethereum smart contracts directly in your browser. This is Remix, so head on over to remix.ethereum.org to get started and follow along with me in this video. So if you used Remix before, you might notice that this has changed quite a bit from previous versions of Remix, and that's another reason I want to make this video is to show you what those changes are and how to use the new version of Remix, all right? And so if you haven't used Remix before, let me quickly explain what it is. It's a browser-based IDE that lets you develop smart contracts directly in your browser. You don't have to install anything on your computer to get started. You don't have to use a terminal. You don't have to use a text editor or anything like that. You can do everything here. So you can create new files like this. I'll show you. You can go here to the sidebar and click the plus icon. All right. I'm going to go ahead and create a new file here called counter. All right. Counter, the capital C, .sol. This is the file extension for the Solidity programming language, .sol, and it's convention to capitalize the name of your smart contract files whenever you create them, okay? So I'll click OK, and here we go. This is the file that we'll use to write all the Solidity source code for the smart contract. And I'll get back to that in a second, but I want to continue on with the tour here of the new version of Remix. So you can create new files for your smart contracts. You can see that there's some already saved here. All right, this is a storage smart contract, okay? There's an owner smart contract, a ballot. So you could even learn a lot about Solidity just by reading through some of the examples that are provided here inside of Remix. But I'm going to show you how to build a smart contract from scratch, step by step in this tutorial. And I'm also going to take you through many different features of the Solidity programming language throughout this series. So in addition to writing smart contracts inside these files, Remix allows you to do a lot more things like compile the smart contracts, deploy them to a blockchain, and actually run a blockchain inside your browser. So Remix is actually a fully fledged IDE. So if you're using this brand new version of Remix, you might have to configure some things yourself. It may look really bare, where you can only see these files and a plugin manager. So I'm going to tab over to a separate terminal window, or excuse me, a separate browser window that I use in my regular Remix setup, which you can see I've got a lot of other things configured. Like here's the files, here's the compiler, and things like that. So I'm going to show you how to add these plugins to your environment so that you can do the same things that I'm going to do in this tutorial. So let's go here to the plugin manager and let's look for compile. Solidity compiler, click activate. And next do deploy and run transactions. So just search for deploy and it should be the first thing that comes up. So deploy and run transactions, click activate. And there you go. Those are all the plugins that you'll need for now in order to follow along with me. So I'll show you what they do. First, this is the compiler. This, takes your source code and compiles it down to bytecode that can be run on the Ethereum virtual machine. And I'll explain that more when we get to that step. And then finally, this allows you to actually run a blockchain in your browser right here. You can see the environment is a JavaScript virtual machine, which basically means it's a virtual blockchain. and it gives you several accounts, and we'll go over all this here in a minute. But I just want to give you a quick tour of Remix and how it works and how to get set up so you don't get stuck if you see the new version of Remix and don't quite know how to use it. All right, so let's get started. Open up your counter.sol file that we created a minute ago and go ahead and do this at the top. Say pragma, Solidity, and then a caret, version 0.6.0, followed by a semicolon. So this line just tells the Solidity compiler which version of the Solidity programming language that we want to use. This must be the first line inside of our file, and we must declare the version like this. Next, we declare the smart contract like this. We say contract, capital C, counter, and then we do an open curly brace, hit enter for a new line, and it should automatically create the closing curly brace for you. All right, if not, you can just type it manually like this. So this is the basic skeleton for the smart contract. We use this contract keyword to declare it, and then we give it a name. Counter is the actual name of our smart contract. And then all the source code for the smart contract will go inside of here. And then all the rest of the code for the smart contract will go inside these curly braces. All right, so the first thing that I want to do is create a basic variable inside of Solidity. So if you're brand new to programming, variables are how we store information. And specifically inside Solidity, we create variables to store things like numbers, strings of text, and all different kinds of things. All right. So I'm going to show you how to do this right now. We'll say, a variable can look like this. We just give it a name like count. We're going to store a basic value for this counter smart contract. Okay. So we're going to follow it by a semicolon, but also we have to give it a type. All right. We have to tell Solidity what kind of information is inside this variable. So in this case, it's going to be a number, all right? And Solidity doesn't have something called number like this. It has something called uint, all right? So uint stands for unsigned integer. So if you think about an integer like, 1, 2, 3, et cetera, et cetera. Well, let me actually do that in comment that out here just so they don't get confused. Like 1, 2, 3, ... These could be integers, but unsigned integer also means that it can't be positive or negative. Sorry, it can't be negative, which means it can't have a sign in front of it or a minus sign, all right? So it means a positive integer. And that's what this smart contract's going to do. It's going to take this number, we're going to be able to read it out from the blockchain, and we're also going to be able to increment this. So think maybe you have an app on your phone where you're playing a game and you want to keep track of the current score. You could use something like this. You could just increment the value by 1. And that's exactly what I'm going to show you how to do. So next, I'll show you how to read the count from the smart contract. We're going to create a function like this. Say function get count. All right, and we follow that by parentheses like this and curly braces. All right. So a function is just a way to create reusable code inside of a smart contract that performs some sort of operation. So inside this function, what it's going to do is actually read this count from this variable and return it back to us so that we can, inspect its value. So if you're going to use this counter to keep score in a game, for example, and you want to know the current score, well, you can call this getCount function to return the current score. All right. So we can do that just like this. We say return count. This is just a special keyword inside of Solidity. Whenever you finish a function, you say return, and then you give it the value that you want to return. In this case, it's the current count. Okay. So next, what we want to do is make this function accessible outside of the smart contract. So we must do this. We say public. So this is the visibility of the function. All right, there's several different things we could do here. We could say this is internal, or we could just not put anything here. We'll learn more about that in the series, but for now, just know that we must use the public modifier here in order to call this function on the smart contract in our browser here in a moment. All right. Next, we add view here, which really just means that we want to view the value of this count here. We don't actually want to change it. And it means something more complex than that, which we'll find out more in the series. But that's essentially what you need to know for now. This just views the count. It doesn't actually change the count. All right. And then so finally, we want to specify the type of data that gets returned here. whenever we say, return count. So we say returns and then a uint, all right? Because we said this was a uint here, or unsigned integer, and we want to specify that it also returns a uint here with this function. So next, what I want to do is create a function that actually changes the count, okay? So this function gets the count, all right? And this is the variable where we store the count. And then finally, we want to create a function that actually updates this count. So we can say function increment count, okay? And we follow it by open and close parentheses. And this one will also be public, just like the previous function, because we want to be able to call this function outside the smart contract. We'll be able to use it in our browser, which we'll see momentarily. All right, and we'll do an open and close curly braces, just like the last function. And then everything that we'll do inside this function goes here. So inside of here, all we want to do is change this count by 1, okay? So we can say count, which references this right here, equals, we'll update it. We'll say count, the current count, plus 1, followed by a semicolon. So whenever we call this function, we're going to take the count and add 1 to it. So anytime we do this, it'll just be like a counter that you might use to keep score in a game, which I talked about a minute ago. So let me talk really quickly about this count variable. So this is a special type of variable called a state variable. The count value actually gets stored to the blockchain itself. All right, so whenever we put this smart contract on the blockchain and we update this count amount, it actually gets saved to the blockchain and we can read its value later. All right, so there are different types of variables in Solidity. There are local variables that you might just see inside of a function, but there's also variables that are more permanent, and that's what state variables are. We have to actually store this value on the blockchain and read it off. So whenever we call this function, we're actually updating the blockchain. We're updating its state, all right? So you'll see here, we used a view modifier for this function. We don't use view here because whenever we call this function, we're actually going to change the state of the blockchain whenever we update this count. So more on that in a minute, but I just want to make a quick note of that while we're here. Now we want to set an initial value for this count. All right, we're returning the value and adding 1 to it, but we want a starting point and we want to specify what it is. So we're going to use something called a constructor function to do this. All right, so that looks like this: constructor, public, and then open and close curly braces. So this is a special function that looks different from these other functions that we just created a minute ago. This is a function that gets run once and only once whenever this smart contract is deployed to the blockchain. So any code that we write inside of here will execute whenever we put this smart contract on the blockchain. So in this case, what we want to do is just set the count value, and we're going to say count equals 0. All right, so that's going to be very explicit that we're starting at 0 whenever we, use our counter. And then when we add 1 with increment count, it'll go to 1. And then, every time we click this, this will change by 1, but we start at 0. And then we can fetch the count like this. And also note that we must use the public modifier on this constructor so that it can be run in the migration. All right, so that's our basic smart contract for now. We're going to come back and modify this code here in a minute, but what I want to do now is actually compile the smart contract and put it on a blockchain so that you can use it and actually observe how the code works that we just wrote, okay? So go to this first plugin, all right? This is the compiler plugin that we added a minute ago. Click compile, all right? Make sure you have 0.6.1 selected here first. Compile. Oops, it looks like I have a typo here. I can't believe I've had that the entire video. That's okay. So, Pragma, Pragma, Solidity version 0.6.0. Sorry, everybody, if you've been sitting here staring at this the entire time, wondering how I'm going to fix this. Here you go. All right, so let's try it again. Click compile. And there we go. So let me explain the compilation step. Essentially what this does is it takes your human readable code and it compiles it down to machine readable code. All right. So you can see, let's see here. Click on bytecode and this shows you, what the value looks like. So I'm actually going to open this in my text editor here and you can see, this is what you get whenever you compile this down to bytecode. All right. Next, let's go ahead and deploy it to our virtual blockchain. So click this icon here and make sure you click JavaScript virtual machine and make sure you have your smart contract selected and click deploy. All right, there you go. That's how easy it is to deploy the smart contract to your virtual blockchain. So you can see the deployed instance of the smart contract here. All right. You can see our two functions. So increment count and get count. So let's click the get count button. This calls it and should return 0 like we expect it to. All right, so you can get count. All right, there you go, 0. And increment count. All right, so then let's get count again. All right, there you go, boom. Try it again, get count, 2. Awesome, it's working. So let me mention this. This is the sort of transaction log that you can see for the smart contract on the blockchain here. So remember when I said we create a transaction whenever you do increment count here? That essentially means that you're, writing data to the blockchain. So the blockchain is, basically comprised of bundles of records called transactions. So every record on the blockchain is essentially a transaction, and those groupings of transactions are contained in bundles of records called blocks, which are chained together to make up the blockchain. Okay, so you can see all the transactions that go through right here. And anytime that we create transactions, we must pay a gas fee. So you can see our account here has gone down. So the rest of these accounts start with 100, but this particular account has gone down, and it will every single time that we do that. So increment count again and again, and our balance keeps changing, okay? Because we're paying for gas anytime we update the state of the blockchain, and we call this increment count function. All right, so that's how you deploy the smart contract to the blockchain and use it and call its functions. Next, I want to show you how to refactor this code a little bit. All right, so the first thing I want to do is actually get rid of this constructor and show you that you can just set the default value of the count here. So you can just say count 0. All right, we can remove the constructor function like this. And then we can just click compile. All right, still works. And deploy. Get count to 0, increment count. All right, it's changing. So we can, change this value to 1 if we wanted to. We can start at 1. Click deploy again. We can skip the compilation step. All right, and see here, get count by default. Actually, let me try that again. We do have to compile. Let's do this. Deploy. Get count. All right, it's 1 by default. Awesome. And increment count still works. Okay, so next what we can do is remove this function and do it automatically with the variable, okay? So instead of, creating a function like this to return the count, we can just call this public. So we can say uint public count equals 1, all right? And that removes this function's need entirely. So let me tell you what that does. This assigns the visibility of this state variable to public, just like these functions are public. And whenever you do that on a state variable, Solidity automatically generates a function for you behind the scenes that gives you this variable value. So I'll show you what that looks like. We'll just click compile, and then I'm going to delete this. Click deploy. And now you can see that there is a function called count here, which automatically returns the value. Okay, so increment count, and then count. Perfect. So next what I want to do is refactor this function a little bit. So change it. And instead of doing count equals count plus 1 here, we're going to say count like this, plus plus. And that should automatically increment the count for us. So that means it's just a shorthand way of saying add 1 to the current value of count. All right. So I'm going to compile that. And then clear this out and do deploy. All right, count, increment count, goes up by 2, or goes up by 1, 2, 2, 3. All right, it works. So that greatly simplifies the code for the smart contract. It reduces the amount of code we actually have to write in order to achieve the same types of results. But I think it's really valuable to see how everything works the long way first so that you better understand what the short way does. All right. So that's an introduction to the Solidity programming language. Congratulations, you just written your first smart contract. All right, let's start programming. So head on over to remix.ethereum.org to get started. This is a browser-based IDE where we'll write all the source code for the Ethereum smart contract in this tutorial. We'll compile it and we'll deploy it to a blockchain all inside of our browser. All right. So go ahead and navigate to the file browser and click the plus icon here. This is how we'll create our first smart contract. So we're going to call this my contract. All right. And the point of this contract is going to be to showcase lots of different features of the Solidity programming language. In particular, we're going to talk about variables, all right, data types, and also custom data structures. All right. So I'll show you that right now. The first thing we want to do is create a smart contract for showing these types of things. We do that like this. We say pragma, Solidity, and then we pass in a version. So I'm going to say version 0.6.0. All right, I'm going to bump the font up here. And now what I want to do is create the smart contract like this. We say contract, my contract. And then we put all the rest of the code inside these curly braces just like this. All right. So the first thing that I want to talk about are variables, okay? And variables are basically just a way of storing information that you can reuse inside your smart contract, okay? So there are two different types of variables that I really want to talk about. All right, so state variables and local variables. So let's start with local variables. So basically what local variables are ways that you can store information that can be reused, inside of functions, essentially. So I'll show you what that looks like this. We'll say function, get value. This will be a function where we basically just return an arbitrary value inside of our smart contract. We'll say function, get value. And inside of here, we will return the value of a basic local variable. All right. So in this case, it'll just be a number. So we'll say uint value equals 1. So let me explain that. This is a variable. It stores the number 1, and the type is an unsigned integer. We'll talk more about that in a minute. Okay. So basically, we can do things with this variable. We can, do math with it. We can say value, add 1. We can manipulate it. We do all kinds of things. But for now, we're just going to return it. All right. So basically, it allows us to store this information and do things with it later. For now, we're just going to return it with this function. Okay. So we'll observe this by saying public pure returns uint. All right. We're actually going to create this function so that we can call it outside the smart contract. All right. So that was how you do a basic local variable. And you can do a lot more with these, which we'll see in this tutorial series. But I want to first illustrate what a local variable looks like as opposed to a state variable. All right. So we can do a state variable like this. Right. So a state variable would look like uint, my uint, and that would look like 1 right here. Okay. So what's the difference between these two things? Well, a state variable here is actually stored on the blockchain itself. And we could potentially even update this value later, especially if we did this, uint public, my uint. All right. This basically creates a way for us to fetch the value of this. All right. So this value here is just local to this function. Value cannot be read anywhere else. Like if we create a new function down here, we couldn't access value. Okay. But if we do create a new function down here, we could access my uint. All right. So that's called variable scope. The variable scope is only available for value inside of this function. But if we create, like function 2, like I was saying a second ago, we can say like get value 2, or say we could say get, let's see here, get my uint. We wouldn't be able to return value here because value is only available inside this function, but we would be able to return my uint. We could say my uint and it will work just fine. Okay. So the other point is that state variables exist on the blockchain. So you can think about the blockchain like a database in this way. We could update the value of my uint later and change it to 2 or 3, right? And that information would get stored in a transaction on the blockchain, and this would actually update. All right. But value here doesn't really change unless we tell it to inside of this function. And its value doesn't actually get recorded to the blockchain. It's just stored in memory inside this function. All right. So that's the difference between a local variable and a state variable. So let's look at some more state variables to talk about different data types. All right. So that's really important. So in this case, the first data type that we looked at is a uint, which stands for unsigned integer. I'll explain that more in a second. But we can also look at like int, all right, and say public my int equals 1. All right. So my int is an integer, and then my uint is an unsigned integer. So what's the difference? Well, an unsigned integer can't have a sign, which basically means it can't have a negative in front of it. All right. That's what a sign is, plus or minus. So that's the difference between an int and a uint. All right. So there are different types of uints. We can say uint 256. All right. Public. My uint 256 could also equal 1. It could also equal 1 billion or something like that. But for now, we'll just leave it as 1. And then finally, we can say, uint 8 public, my uint 8 equals 1. All right, so there are all different types of unsigned integers. And so what's the difference between uint 256 and uint 8? Well, these are just different sizes, and this specifies, how big the actual number can be. So if you don't want the number to ever be very big and you want to optimize performance inside your smart contract, you would use something like uint 8. But if the number needs to be really big, and you need to allocate more space for it, and you're willing to sacrifice performance, you can use uint 256. All right. So what's the difference between uint and then what is uint without any number at the end? Well, it's just short for uint 256. So by default, it defaults to this value right here. Okay. All right. So that's how you can work with numbers. Let's look at some other data types. All right. So these will be state variables. I'll take this away. I'm going to leave it for now. Let's look at strings. All right. So what is a string? Well, basically, it's just, a collection of characters that you see on your keyboard strung together, surrounded by quotation marks. So a string could look like, hello world. All right. We could store these inside of smart contracts as well. We just say string, all right, public my string equals hello world. Okay. So that's what a string looks like. All right. And also notice that I'm putting the type here before the variables. This is what it means for Solidity to be a statically typed language. You must declare the type before you do the variable. Sorry, this should be mesh string. And also, once you assign this value to a string, you can't later assign it to a number or something like that. That's also a feature of a statically typed language like this. All right. So that's how you would store a string. You can do that here with value as well. This could be my value. You could change this to string. Value, could be hello world. Right. And you can just return value like that. That's how you'd work with a local variable. All right. So, let's see here. We can also do, bytes 32. So that's going to be more performant than a string, which you might want to use in some cases. So like bytes 32, public my bytes 32 equals hello world. All right. So you can see that there are sometimes you can do things the same way, the same thing different ways in Solidity. And a lot of times the reason for that is performance because, a lot of times, you're thinking about optimizing how your smart contracts work to minimize the amount of money that has to be used inside of transactions and also the amount of time that something just takes on the blockchain because blockchains by nature are very slow. Okay. So the next thing I want to talk about, another data type would be an address. So on the blockchain, every user that's connected to the blockchain has an address. Every smart contract on the blockchain has an address. This basically tells us where it comes from. So we can store addresses in the smart contract like this. We can say address public my address equals, I'm just going to paste an address in here from our screen. All right, like this. So this is what an Ethereum address looks like. So if you have MetaMask installed or something like that, you can just put your own Ethereum address, or you can go to a website like Etherscan and just find any Ethereum smart contract address and paste it in here. So make sure you don't put quotation marks or anything like that around it. Just put the raw address here, of course, with 0x in front of it. All right. And we just store that as an address type on the blockchain. All right. So the last thing I want to show you in this video are how to create your own custom data structures. And we do that with something called a struct. All right. So you can create a struct like this. We can say struct, my struct. All right. And then you just put put curly braces after it like this. So structs are basically a way for you to just model any arbitrary data. All right, so this could, represent a person. It could represent, a vote, or really anything. All right, and you can put your own data types inside the struct. So for now, we'll say, uint, my uint, and then string, my string. All right, so this, for example, this could be a person, and the person could have an ID, and the person could have a name. All right. So sorry, I don't know why this keeps highlighting things. It's kind of annoying. But you get the idea here. I could create, this could be a person. This could be a vote. This could be, a ballot or something like that. All right. Or, whatever you're voting for. So for now, let's just keep it as my struct. And we'll say my int. Just being consistent here with the other examples. All right. And then my string. Okay. All right, now let's go ahead and create a way to fetch this struct. I'll show you how to use it. So this just defines the struct right here, but we haven't actually used it anywhere inside the smart contract. So we'll do that like this. We'll say my struct. So this is, you defined a custom type here, and we'll put the custom type before the variable. Say public my struct equals my struct. This is how you instantiate it. And say 1, and then hello world. All right. So you can see that the struct is sort of a way of grouping values maybe. So we do my int here, like is 1, and my string is hello world. We can just put those inside of a struct like this. So public my struct equals, the uint is 1 and the hello world is the value. Okay. All right. So let's watch all this in action. Okay. If you didn't watch the last video on how to set up Remix, go ahead and check that out. But if you don't, you need to check that out because I'm going to compile it and you may not actually have this button here. So if you don't have this button, go check out that last video on how to find it. Really quickly, you can go to the plugins and just search for the compile plugin, and then also the deploy and run plugin, and that will get you there. Okay. So let's compile it. Make sure you do Solidity version 0.6.0. Compile the smart contract. Actually, let's do 0.6.4. Let's try that. Okay, so we have a little issue here. Let's go back instead of get value. Let's change this to go back to the int or uint. Value is 1. All right, let's just avoid this problem altogether. Okay, so make sure your smart contract looks like this. I'll have the code for this down in the description below, so if you have any trouble, you can just copy and paste what I have. All right, so I'm just going to do 0.6.4, or let's just do 0.6.0. All right, let's be consistent here. All right, we'll do that. So it's compiled just fine. Now let's go to the deploy step. All right, so this is from earlier. Clear this out. Make sure you click it. And make sure you click JavaScript virtual machine. Just keep the first smart contract selected and click deploy. All right, there we go. There's a smart contract. So now we can fetch all these values. So get value should return 1. All right, boom, there we go. So my address here should return this value. All right, there we go. My bytes 32 should return this encoded, which we should see here. Boom, there we go. All right, so you could convert this in your front end, but that's the more performant way to pass the data around. So my int should be this. All right, my string, hello world. Yep, hello world. My struct should return these two values, 1 and hello world. Yep. My uint, all right. And my uint 256 and my uint 8. All right, perfect. So all these work just like we expect. We're going to cover two essential features of the Solidity programming language. These are going to be two different data structures. The first one is going to be an array, and the second one is going to be a mapping. All right, and I'm going to explain what both of these are and how to use them inside this video, okay? So if you haven't already, head on over to remix.ethereum.org to get started. You know, this is just an in-browser IDE that lets you write Ethereum smart contracts directly in your browser without having to install anything on your computer. It's really nice. So go ahead and create a new file here. I've got one called mycontract.sol. And inside of here, make sure that you add the version of Solidity that we're going to use in this video. So 0.6.0, just like this. And then also go ahead and create a smart contract called mycontract like this. All right. So now let's talk about arrays. So what are they? Basically, they're just a way of storing information, basically a list of information in order. So you might be familiar with this from other programming languages, but if you're not, I'll show you what a basic array looks like inside of Solidity. All right. So you can create one like this. Let's go ahead and delete this out. And I'll say uint. All right. And then open bracket, close bracket, public uint array equals 1, 2, 3. All right, so that's how you create a basic array inside of Solidity. All right, so I'm gonna bump this font up a little bit. So essentially what it is, it's a list of information. In this case, it's just a few numbers, all right? 1, 2, 3. There's 3 items inside of this array, and they're in order, right? We can access each of these values based on the order that they exist inside the array. We call that the index, which we'll see here in a minute, okay? So basically, arrays inside of Solidity have a very specific type inside of them. So in this case, this is an array of unsigned integers. So if you're not familiar with those, go ahead and check out that previous video where I talked about different data types. Basically, this is just an integer that can't be negative. And, you know, we create an array of them like this, all right? We call it public so that we can read it outside the smart contract, and then we give it the variable name of this array, which is just uint array, right? Just an array of unsigned integers. We can also create arrays with different types, like strings, for example. We can do that like this, say string, all right? This is a string array, public, and we'll just call it string array. And we can create items inside of it like this. We'll say apple, banana, and carrot. All right. We can also create arrays without any values initially. Right. We can basically just say string public my array. All right, we don't add any items to the array. We just create it, we initialize it here, all right, inside the smart contract, and then we can add items to it later inside of functions and things like that, all right? So I'll show you how to do that right now. So basically, you can create a new function like this, say function, all right, we'll say add value, okay? And we'll pass in a value to this function like this. We'll say string memory value, and whatever we do inside of here, we'll add it to this array right here. All right, we'll say public, and we'll pass in the value like this. We'll say values push, and then value. Okay, so let me explain what this does. Essentially, it just takes this values. Actually, sorry, I said my array here. This should be values. Okay, so it takes this array that we created right here, values, and then just adds the value to it from the function. So we use value with an underscore in front of it here. That just represents the value that's being passed in, and we add it to this array like this, which is a state variable, right? We store it inside the smart contract. Okay, so we do that with the push function. Okay, so what push does is it takes one argument, this is the value here, and adds it to the end of the array. Okay, so if we had done this to, uint array, it would, or sorry, let's do string array since this is a string. Let's say we passed in, let's say like dog food inside of here, it would add dog food to the end of the list. Okay. So that's what push does. It adds an item to the end of the array. Okay. So we'll see that in action here in a minute when we actually test this out in the compiler here in a minute, or actually in the runtime environment. So the next thing we'll do is show you how to get the number of items that have been added to this array. Okay. So function value count. All right. And we'll say public view returns, say uint. Okay. And inside of here, we'll say return values. All right. This is values right here. Dot length. All right. And that will let us know how many values exist inside this array. Okay. And really quickly, it looks like I have a typo here. Say function. Sorry about that. Okay. So the last thing I want to show you with arrays are how to do two-dimensional arrays. So what does that mean? Well, you see how, these arrays have, numbers inside of them, and these have strings inside of them. Well, you can create an array that has other arrays inside of it. Okay, that's what a two-dimensional array means. So I'll create one like this. Say uint. Basically, it'll be a two-dimensional array, and then the innermost elements will be numbers, which we'll see here in a second. All right, like this. Say public array. We'll call it 2D. All right, equals 1, 2, 3, and then 4, 5, 6. Okay. There you go. That's a 2D array. So you can see there's an outer array here and then two inner arrays, which contain 1, 2, 3, 4, 5, 6, and those are unsigned integers. And so you just declare the 2D array like this. Okay. All right. So let's watch some of this in action. Go ahead and click on the compiler here. We'll click compile contract. If you don't have this, you can install it from the plugins down here. Okay. All right. So that worked just fine. No issues. Then let's go to the runtime environment so we can deploy the smart contract like this. All right, click deploy. And there we go. So let's interact with this. We'll do it one by one here. Let's look for the uint array. All right. So I'll explain what this does. Essentially, this function does not return the array. All right. Remember, whenever we put public, we put the public visibility on state variables, it gives us a function, right? These are the functions right here that it gives us for free. We don't have to create a function like this. It does it automatically behind the scenes whenever we call this public. Okay. And so the function exposed by this variable right here, uint array, doesn't actually return the array itself. It returns a function that we can pass indexes or indices into to read each item out individually. So I'll just show you what that means. That might sound kind of confusing. Just watch this and I think it'll explain everything. Okay. So uint array, basically I put in 0 right here and it will return the number 1. All right. See, boom, done. So this is an important thing to note. Arrays in Solidity, like most other programming languages, are what's called zero-based index. All right. So if you put in the number 0, it will return the first item. If you put in the number 1, all right, it'll return the second item. All right. And then, put in 2, it'll return the third item. And if I put in a number, an index that doesn't have a value, it will throw an exception. So if I put 99, all right, boom, there you go. So VM error. All right. So you can see that in action also with the string array. All right, if I put in 0, that's the first item in the list. All right, string, boom, done. Okay, and then the next item would be, let's see here, 1. Okay, all right, and then the next item would be 2. All right, and the next item would be 3. Or you know what I'm saying. If I put in a number, it does the same thing. It'll just basically return a VM error. Okay. All right. So that's the string array. So let's look at values. So in order to read items out of there, we can do get value. So we can add a value like this. So that's going to be a string. We can just say foo. All right. Click add value. All right. And then we can add another value. We can say bar. And then add another value and say baz. All right. Boom. So now we can get the value count to see how many items exist in this values array. All right. Value count is 3. Okay. And then we can read the first value like this, put in 0. And there you go, foo. The second item at index 1. All right, bar, baz, and then, if we do 99, it'll do a VM error, okay? Okay, the last thing I want to look at is how this 2D array works. So essentially, we can see array 2D, and here's how we access each item in there. So we basically put in 2 arguments. We put the index of the first array and then the index of the second array. So 0, 0 should be 1, all right? All right, then 0, 1 should be 2. All right. So likewise, I can put like 1, which would be the second array in here, and then at position 1 should be 5. All right. So 1, 1 should be 5. All right. And then 1, 2 should be 6. All right. There you go. That's how you access 2D arrays. All right. So that's pretty straightforward. Where I'm going to show you a really critical data structure that you're going to use all the time whenever you develop smart contracts for Ethereum. So first and foremost, what is a mapping? Well, it's a data structure inside of Solidity, kind of like an array, which we talked about in the last video. An array is a linked list of items, or sorted list of items, I should say, that you can, put information inside of and do things with it. You can fetch the items back out later. You can do lots of stuff with them. So a mapping is similar in that regard, but it's a little bit different. Okay, a mapping is a key value store where you can look things up based on a key and then get a value back. So what do I mean by that? Well, here's an illustration that might help. Here is a key value relationship. Okay, it's a table where you have a key here and then the corresponding value. And essentially the key is unique. So there's only one K1. And if you look information up on this table, if you look for K1, here are the corresponding values, right? K just stands for key in this case. So you could kind of assume that there's no K and just say 1, 2, 3, 4. So if I say, show me the information in row 4, well, here's the information in row 4. Or show me the information in row 5, here's the information in row 5. So also, if you want to create new information on this table, you just say, here's the information that would go on K6, for example, and you could give it some new information, and later you could go and look that back up, okay? So that's what a mapping allows you to do inside of Solidity. It is a key value store. This is similar to other programming languages where you might have a hash table or hash or maybe an associative array, okay? So I'll show you how to create a mapping inside Solidity like this. You just say, use the mapping keyword, mapping, all right? And then you tell it the key, you tell it the value, and then you give it a name, like my mapping, all right? But I'm going to repurpose this and show you what it would look like for a real mapping. So in this case, let's do a mapping of names. So we'll call this names. So names like Adam, Brian, and Carl. All right, we'll call it public. And what you do with the key and the value here is you specify the data type. So the names here are going to be strings. So I say string. And the key is going to be an integer. We're just going to store information for like name 1, name 2, name 3, name 4. So we'll say unsigned integer or uint. All right. And that's how we'll do it. It's pretty simple. It's a pretty simple lookup. We'll just say name 1 is going to equal 1 string. Name 2 is equal to a different string. We can set that information and we can look it up. So let me pause here and talk about how a mapping is different from an array. In the last video, that's what we talked about. And you could store names inside of an array, but there's a few limitations. One is that arrays are a zero-based index. So like if you want to look up the first name, you have to look up name 0. And if you look at the second name, it's name 1, and so on and so forth. Sometimes you just want an ID, right? And that's essentially what this does, is name 1 will be accessible by the ID 1. So it makes the blockchain work somewhat like a database where you can just look information up. And mappings are one of the primary ways that we use Solidity smart contracts somewhat like a database, okay? Because don't forget, the blockchain essentially is a database. You can put information on it and read it back out later, okay? It's a public ledger, and this is a way that you sort of treat it like a database. You give it an ID, and then here's the information that corresponds with that ID. So you could use mappings in different ways than just this, which we'll see later, but let's continue on with this example. All right. So let's actually add some names to this mapping. I'll show you how it works. We'll do this inside the smart contracts constructor function. I'll say constructor. All right. And then don't forget the constructor function is just the function that gets run whenever the smart contract is initialized or deployed to the blockchain. So it gets run once and only once. And here's how you add the names to the mapping. Basically, you reference the name, so it'd be names, and then use these brackets, all right? And then you say like name 1, all right, is equal to, we'll say Adam, all right? So names 1 equals Adam, all right? We can do that again for names 2 is equal to Carl. Names 3 is equal to, well, let's do Carl. Let's do an ABC order here. Say Bruce and then Carl, okay? So basically, we're going to say name with an ID of 1 is equal to Adam. Name the ID of 2 is equal to Bruce, and names ID of 3 is equal to Carl. So we can read this information back out of this mapping directly because we call it public here. All right, this is a way that Solidity gives us a function to read these names back out. All right, so let's go ahead and compile this and run it. If you're having trouble following along, don't forget to go to remix.ethereum.org and create a new contract called mycontract.sol, and you can just use the source code at this point in the video. Okay, so go ahead and go to the compile step. All right, and then click compile. All right, we've got a little issue here. So the constructor needs to be public. My fault. Let's fix that. All right, and then deploy. Okay, so now we can just read the names out of the mapping. So say names 1. All right, Adam. Names 2. Bruce. Names 3 is Carl. All right, so what happens if we do name 4, empty string? Okay, so essentially what the mapping does is if you provide an ID that doesn't exist, it returns a default value. In this case, it's just an empty string. Okay. All right, so I'm going to kill that contract and go back to our development mode. So let's continue on with this. Let's talk about how we can treat the blockchain more like a database with mappings. Essentially, what we can do is model arbitrary data and more complex data, okay, than just like strings or numbers or something like that. We can create mappings of our own custom data structures. So in one of the last couple of videos, we talked about how to create structs, which are a way to create your own data structure inside Solidity. So let's create a database of books, okay? So we start off by creating a book struct like this. Say struct book, okay? And inside of here, we say string title and then string author, okay? So this is how we create our own custom book with 2 attributes, title and author, both are strings, okay? And we can create a mapping of these books like this. Say mapping. We do an ID of an unsigned integer, uint. And we say book like this, okay? Then public books. So that's how we create our books mapping. So we can say book 1, and then we can add a new book here with a title and an author. And then actually, let me lowercase this. And then we can say book 2, title and author, et cetera, et cetera, et cetera. It'll work just like a database. So now we can create a special function to add a book. So we won't do it automatically in the constructor like this. We'll create a special function to add a book like this. Let's say function add book. Okay. And then we'll just do public. We'll add the arguments in a second, but here's how we add it. So we say books. Well, actually, let's go ahead and add the arguments. So what do we need? We need to tell it the ID, all right? And then also the title and then the author. Okay, so we'll say uint ID and then string memory author or title and then string memory title. Okay. So now with this information, we can add the book to the mapping like this, just like we did here. We say books ID equals book. This is how you create a new book. And then say title and then author. All right. So that's how you would add a new book to our database. Okay. The next is, well, let's just go with that and observe it in action. So let's compile it. Does it run properly? Okay, I see what the issue is. Sorry, I did title twice. As me title and let's see, title and then author. Okay, we'll try that again. Yeah, my fault. All right, so now let's compile it and deploy it. All right, and then let's try to add a book. So we can say book 1 will be my book, and we'll say the author is Dapp University. And then say book 2 is, let's say, Tom Sawyer. And then we'll say Mark Twain. All right. And then we'll say book. Oops, that was book 1. I think I did book 1 twice. Let's just see. So let's go ahead and read it out. Look at book 1. And then there you go. Title, Tom Sawyer. Author, Mark Twain. So sorry, I actually overwrote the first book. My fault. Let's go ahead and do book 2. Will be 2. And we'll say War and Peace. We'll say Tolstoy. Let's give it the last name. And books 2, War and Peace by Tolstoy. Okay, perfect. All right, so that's how you would add books with this mapping. So the next thing I want to show you is how to do nested mappings. All right, so this is a pretty critical thing to understand with Solidity because it allows you to model more complex data, all right? So in this case, we just created a way to store books and store, all the books that would belong to the smart contract. But what if you wanted to store, books that belong to just you, right? Or books that belong to someone else. And then sort of namespace those books under your username or your account on the Ethereum blockchain. Well, that's what a nested mapping would allow you to do. So what is that? Well, a nested mapping is essentially just a mapping inside of a mapping, all right, or a mapping that returns a mapping. So you basically say mapping, and then key, and then the value would be another mapping with key 2, and then value 2, all right, and then public, my mapping. Okay, so in this case, what we want to do is model all the books that belong to us or someone else. Okay, so we can do a mapping that looks just like this. We can basically have a books mapping with an ID, a uint, and then a book, but we can assign them to specific users based on their Ethereum address. So the key here can be address, the address type, okay? So basically I can say, pass my address in and then get all of my books based on their ID. Okay. So I'll show you how that works. Say function add book, or I'll say add my book and say uint ID, string, memory, title, string, memory, author, public. And what we'll do here is basically just store it based on the user who calls the function, all right? So Solidity has a global variable called message sender, or msg.sender, that allows you to capture the address of the person calling the function. Okay, so in this case, we'll do it like this. We'll say my books and pass in msg.sender. All right, this will be the Ethereum address of the person calling the function. All right, then you use a nested mapping and then use another bracket like this and say ID and then equals book and then title and then author. All right. So look, it works just like this. Here's how you would do a normal mapping, right? So you see that here. And then that just returns a second mapping, and then you do the same thing again, okay? But you do different keys. So here's the key for the address, and then here's the key for the actual book that gets returned, okay? So I'll show you how that works in action. Compile it. Okay, so we got an issue here. Title, author. I think I had a typo here maybe. Let's see here, undeclared identifier. Okay, so I forgot to change this up here. So my books should be the name of the mapping, not my mapping. All right. So try that again, compile, and then we'll deploy. All right. So now let's see the my books in action. All right. So what we want to do is actually get the address that we're currently using. So go up here to this menu and copy the account. All right. So we'll keep that handy. But we'll go ahead and add a book. Let's say IDB1. And we'll say, War and Peace. Let's be Tolstoy. All right. And then add book. And then we'll say, book 2. And then we'll say the Republic. Plato. Add my book. All right. So now we can paste in, click on my books, right? Let's see here. So just paste in your address here, okay? And then we'll look at Uint 1, click call. There we go, War and Peace. Then 2. There we go, the Republic. So you can do the same thing, you can switch accounts here, click a different account, click copy. And then, we could do book 1 for them, could be Will to Power. This could be Nietzsche. I think I spelled that right, might be wrong. All right, and then click my book here. Oops, let's just do that. Click 1, click call. And there we go, Will to Power by Nietzsche. All right, so that's an overview of how to use mappings inside Solidity. All right, this is a pretty common thing to use for like database type development for smart contracts. There's lots of different ways you can use mappings, but that gives you an introduction on how to use them inside your own smart contracts. So we're going to cover 2 different essential aspects to developing Ethereum smart contracts. The first will be conditionals, and the second one will be loops. All right, and you need to know both of these things in order to effectively become a blockchain developer. We'll start off with conditionals. All right, so what is a conditional? Well, basically, it's a way to determine that something happens in a programming language based on whether a condition is met. That's not a very good explanation, so I'll just demonstrate what I mean by that. Basically, like if something happens, then do something, right? And if it doesn't happen, then do something else. All right, this is not really code. This is just sort of a pseudo code explanation of what I mean, right? So this is commonly referred to as like control flow in programming or computer science or control structures. So I'll just show you how this works in action. Let's go ahead and create a function that determines whether a number is even or not. All right. We'll just create a new function like this. We'll say function is even number. All right. And we'll say this is public. Say view returns uint. All right. And inside of here, we'll just determine whether the number is even, like the function says, and we'll return a Boolean true or false. So let's add the number to the function like this. We'll say uint number. And what we'll do is take this number and determine whether it's even. So how do we do that? Well, essentially, we divide the number by 2 and see if there's a remainder. So what do I mean by that? So, for example, 4 divided by 2 will equal 2. All right. 5 divided by 2 will equal, let's see here, 2.5 or 2 remainder 1. So if you think about like, elementary school mathematics, 2 remainder 1, and, so on and so forth. Basically, this will not equal an even number. It will be, it'll be a fraction or odd or something like that. All right. So basically like do like this. So say if, number, and then we'll say modulo 2, equals 0, then we know that it's even. And if else, return false. Okay. So what is this? Well, this is called a modulo operator. This is the percent sign. Basically, this determines whether there is a remainder. So like I showed you a minute ago, like 5 divided by 2 equals 2 remainder 1. So this modulo will basically represent the remainder here, 1. So, 5 modulo 2, the modulo will be 1, all right? But for even numbers, the modulo or the remainder will always be 0. So let's say like 4 divided by 2 equals 2 are 0 or 2 modulo 0, all right? So that pattern persists across all numbers, right? So basically this is how we determine whether the number is even or not. This is the condition, all right? So if this condition is met, then we want to do something. In this case, we just want to return true, all right? And if it's false, or if it's not met, then we just want to return false, okay? It's a really simple example that we'll start off with. So let's go ahead and compile that. Compile it. So we got some problems here. So this is saying bool is not, okay. So basically, this should be bool here. Sorry, guys. All right, so I specified the wrong return value. This should always return a Boolean. Sorry if you caught that earlier. All right, there we go. So now let's compile it and deploy. And let's take a look here. So is even number, we'll say is 1 an even number? Nope. Is 2? Yes. All right, is 3? No. And is 4? True. Okay, awesome. So this function works. Now we can use this function to create an even more complex workflow like this. We'll create a array inside of here with numbers, and we'll check if the numbers inside of the array are even or not. All right. So I'll say int, or say uint, say public numbers. And I'm just going to set this equal to numbers 1 through 10. All right, like this. Boom. So now let's just go ahead and compile this and deploy it. And see like numbers. We can say the first one, is 1. Second one is 2, etc., etc. All right. So now what we can do is create a function that will actually iterate through this entire array and then count all of the even numbers. All right. So what we're going to do inside this function is create another conditional like this. So a control structure, conditional. And then we're also going to do a loop. All right, which is what I mentioned earlier at the beginning of the video as well. So we need both of these things inside this new function in order to get the count of even numbers inside this array. All right. So a function, we'll say count even numbers. You can call it even numbers count if you want to, but that's just what we'll do for now. Public view returns uint. Okay. And so what we want to do is create a count variable. Say uint count equals 0. All right. And then now what we want to do is loop through this entire array to count all the even numbers. So here's the first introduction to a loop. So what we're going to do is a for loop. Okay. You might have seen this inside of another programming language. Maybe you have a JavaScript background. Maybe you are brand new to programming. That's okay too. So I'll explain what this is. So what this loop does is it essentially executes code inside of here, runs code, and it keeps doing it until the condition is met inside of here. So a for loop kind of is like a conditional. And that's actually really a while loop. So really a for loop, it does it for it iterates over this entire thing, right? So not a very good explanation, but I think you'll get what I mean when you see it in action. Okay, so just bear with me and we'll continue forward. So what I want to do inside of here, this is a very common pattern. You might have seen it in JavaScript. I'm going to say uint I equals 0. and then I less than number, or yeah, let's do numbers dot length, and we'll say plus plus, say, or sorry, length I plus plus. Okay. So what it's going to do is it's going to count through each number in this array. So we'll start at 0. This is going to, I is going to stand for index here. And then for each number in the entire length, all right, as long as I is less than the number's length, do this. And then whenever this is done, do this. All right. So this, let me break that down again. This is the initial value for the variable. That's sort of like the counter for the condition. And then this is what, they basically do this until this is, while this is not satisfied. And then after each time in the loop, do this. Okay. So I'll just show you what I mean by that. Inside of here, we'll say if number is even number. All right, we can use our function right here and then pass in I. Actually, let's do this. Let's say numbers I. All right. And then we'll say count plus plus. All right. Followed by this, and then we'll return count. So what does this do? Well, it loops through all these, and then it checks to see if the number inside of here is an even number. And if it is, then it increments the count. And if not, it does nothing, and it moves on to the next item in the array. All right. So let's just watch that in action. We'll go here, compile. All right, we've got an issue here. Let's see here. Function count even numbers, public view. Oh, that's a syntax error. Returns, my fault. All right. And then compile and deploy. Kill this one. So we'll say, count even numbers. And there we go. It's 5. Perfect. So it works. As you can see here, 1, 2, 3, 4, 5. There's 5 even numbers in this array. So we could change this, and this would also return a different count based on, how many even numbers are in there. So that's how you use a for loop inside of Solidity. And these has many applications, which you can see if you start developing smart contracts. But here's the basics on how to do it. And here it is in tandem with conditional like this, right? These control structures. So the last thing I want to do is show you how to do conditionals with in a different setting. So let's just say address public owner. All right. And then what we're going to do is store the ownership of this smart contract whenever it's deployed. So basically, an Ethereum account is going to put this smart contract on the blockchain. And what we can do is determine whether the owner is the person who deployed it or not. So do that like this, a constructor, public. Don't forget the constructor is the function that gets run whenever the smart contract's deployed to the blockchain. So you can check that out, explain that more in the previous videos, but that's it for now. Say owner equals msg.sender. Okay, and then we can have a function like this that just checks whether the owner is the smart contract owner. So function is owner. All right, we'll say public view returns bool. Okay, and inside of here, we'll say, if msg.sender equals owner, return true, and then else, return false. All right, so that's what's going to check whether this person is the owner of the contract or not, okay? So we'll see that in action, but really quickly, I want to refactor this to show you how you can actually get rid of a conditional when you don't need it, all right? So we see this really simple conditional pattern here, if condition, return true, else return false. That's really okay when you're just trying to understand how conditionals work in the first place, but you don't have to write all that code, all right? So for this basic function, you can do this. You can say return msg.sender equals owner. All right. And that's because essentially this condition right here is already going to return true or false. So if the function returns true or false, you don't need to specify the return value of true or false inside the conditional. Okay. All right. So let's just compile this and we'll deploy it. We'll clear the old one here. So count even numbers, does it still work? Yes. All right. So let's say is owner. True. All right. If I change the address to a different one, say is owner and false. All right. So that's an introduction to conditionals and loops inside of Solidity. So these are both really essential aspects to developing Ethereum smart contracts. So you really want to make sure you understand these. So up until this point, we've kind of covered topics individually, like arrays, for example, variables, and we've kind of just created, a single contract called my contract that demonstrates these principles in kind of an abstract way. Okay, and I think that can be a helpful approach sometimes. But what we're going to do in this video is actually build a smart contract that has a specific purpose that's going to illustrate several different concepts or introduce you to several different concepts that we haven't quite seen at this point in the tutorial series. Okay, so what we're going to do is create a smart contract for a hotel room. And what's going to happen is basically the user is going to be able to pay this smart contract to book the hotel room, and it will automatically open the room for them and allow them to occupy it. So let's go ahead and get started. And when we build out this use case, you're going to see several different things in this lesson. Let's see here, like how to work with Ether, pay smart contracts. Let's see here, how to do modifiers. Let's see, visibility. And also events and enums. All right. So don't worry if this looks like an overwhelming list. It'll all make sense as we build out this entire project. And it won't even take very long. But once you finish, you'll understand all these things and how to create a hotel room smart contract. All right, so the first thing that I want to do is create a way to actually book the hotel room. All right, so we'll start off with a function. Let's see your function called book. All right, and what we'll do is, write the logic inside of here to book it. All right, and what we're going to do is basically allow the user to pay this smart contract with this function, and it will transfer the payment to the person who deployed the smart contract. In this case, we'll just call it the owner. Okay, so let's go ahead and model the owner. So I'll say address, payable, public, owner. All right, this will be a state variable. And remember, this state variable gets written to the blockchain. All right, so the blockchain will know who the owner of this smart contract is all the time. And this is who we'll send the payment to whenever this hotel room gets booked. Okay, so let's store the owner. We could assign it here and hard code the address, but what we want to do is dynamically assign it to the person who deploys this smart contract. They'll essentially be the creator. Okay, so we'll say constructor. This will be the function that gets run whenever the smart contract is created. Right? Say public and owner equals msg.sender. All right, so let's recap this here. Don't forget, msg.sender is or message sender is the user who deploys, the user who calls this function in Solidity, right? So anytime you reference msg.sender or message sender, this is an Ethereum address of the user who's calling this function, all right? And this constructor function is the function that gets called whenever the smart contract is created. It's once and only once whenever the smart contract is deployed to the blockchain. All right. And we're saying the person who deployed this, the person who called this function, they are the owner of this smart contract. Okay. and we store that ownership here in a state variable. This is actually written to the blockchain. All right. We say it's an Ethereum address type. All right. Address. And then payable, we must use this whenever we create the variable so that this owner can actually receive Ethereum or Ether for the payment. And then public so that we can determine who this person is later. Okay. All right. So inside of the book function, what we want to do is pay the owner to book the hotel room. Okay. So we do that like this. We say, owner transfer. And then we want to actually, send the Ethereum that comes in with the transaction whenever this function is called. So just like we have msg.sender or message sender, we also have message value here, msg.value. All right. So whenever we call the book function, we can send in a payment. We can send in Ethereum, Ether, and we can determine how much that is right here with message value. All right. So in order to do that, we must call this function payable. All right. And then now whenever we call this function, we'll be able to just transfer the ownership. Sorry, not transfer the ownership. Transfer the Ethereum payment to the owner. All right. Okay, so that's step one. Just pay the owner to book the hotel room. Now, the next thing that we want to do is we want to make sure that we can actually book the hotel room, all right? So if it's already been booked once, we don't want it to book again, okay? So we can keep track of the hotel room status, all right? We can basically say, is the hotel room vacant? Or is the hotel room occupied? All right. And then what we can do is inside this function, we can check to see whether the hotel room is vacant or occupied before we book it. All right. So we can keep track of this status like this. We can use an enum. All right. We'll use an enum. All right. So the enum will look like this. Let's say enum. Statuses. Okay. And then we'll say vacant or occupied. All right. So what this enum does is it keeps track of a collection of options basically that will never change. And we can reference this collection of options, in this case statuses, and we can change it. We can kind of see what the current status is. So we can track it like this. We can say statuses, current status. All right. And basically we can set the current status like this. We'll do it in the constructor. Basically, we'll set a default status whenever the smart contract is deployed, right? Just like we set the owner, we can also set the default status. Say current status equals statuses that vacant. All right. So do equals here. All right. So basically, whenever we deploy the smart contract, this will be created whenever the hotel room is not booked yet. So we'll say the status is vacant. All right. And that changes it, or that keeps it. That basically is tracked here. Okay. So now what we want to do is whenever we book the hotel room, we also want to change the status to occupied. All right. So we can do that like this. We say current status equals statuses dot occupied. All right, and that will actually change it. Okay. All right, so the next thing that we want to do now that we've tracked the status, we have a way to track it right here. All right, we update the status whenever we book it to show that the room is occupied. And whenever we deploy the smart contract for the first time, we set the default status. All right, the default status is vacant because by default, no one will actually be in the hotel room. All right. So now we have this book function. Okay. And this book function will update the current status to occupied. All right. And then it will transfer the ownership of the ether, or it'll send the ether to the owner. All right. I keep saying transfer ownership. My apologies. That's a different concept when you're talking about an ownable smart contract. So anyways, I know this book function, by the way, is not properly named. Like when you book a hotel room, you don't automatically occupy it. Don't worry about that. This is going to change in a minute. But I just wanted to make note of that really quickly. All right. So the next thing that we want to do is add some constraints to this. Okay. So basically we have a function that will, update the status and transfer the ownership. But we have a problem, right? Like you could book this twice, right? The same hotel room, and it doesn't check to see if it's currently occupied, right? And it doesn't check to see if you paid the right amount, right? So we need to add these things to the smart contract in order for it to even make sense, okay? So Solidity has these things called requirements, so require. All right, and basically what we can do is ensure that some conditions are met inside this smart contract before this code gets executed. So for example, we can check the price and we can check status. And basically we can say, if you didn't pay the correct amount, then don't do this. And if you didn't, if it's booked already, if the status is wrong, then also don't do this, right? So it's two conditions that we want to implement in order for, a successful booking to take place. So we can require that the status is correct like this. We can basically say current status equals statuses vacant. All right. And so we can also give it a error message, currently occupied. All right. So let me show you. Basically what's going to happen here is if they try to call book twice, or, while it's currently occupied, and this condition will basically say, if the current status is occupied, then this will fail. So let me explain why. Basically, what require does is it checks to see if this is true. Okay. And if it's true, it will just resume execution. Like this line will just basically skip, and these lines will be called, right? But if this expression evaluates to false, then it will halt, all right? It won't satisfy the requirement. And basically these lines won't execute, and any like Ethereum sent in the transaction will get reverted and sent back to the user, okay? Or at least any unused ether at that point, all right? So also we can specify an error message here, which is really nice in the transaction. So if this fails and it doesn't meet this condition, we can say that it's currently occupied, okay? All right, so the next thing will be, we want to check the price, right? We want to require that the user actually sent in enough. We checked the status, now we want to check the price. So we'll do that like this. We say require current, let's see here. How do we want to do this? We'll say, we'll check message value, okay? MSG, or message value. And we want to require that it's greater than or equal to an amount. So we'll specify the amount here. We'll say it's greater than or equal to 2 ether. Okay. And if it fails, we can give a message. We can say not enough ether provided. Okay. So here's our 2 checks. All right. So basically, what's really cool about Solidity is we can abstract these requirements into something called modifiers. And that's the thing I want to show you next. All right. So here's the requirements. Now I'm going to talk about modifiers. So basically what modifiers are is they allow you to take these lines out of your function and put them into modifiers that will go on the function like this, right? And they'll run before the function gets executed. So let me show you an example. So we can create a modifier like this, a modifier that says only while vacant. And inside of here, basically, we can just move this like this. And this will run the requirement. And then after this line, we need to do an underscore and followed by a semicolon. And this will basically execute the function body. All right. So now we can just say only while vacant here. And that will do the exact same thing. All right. So we've just moved that requirement statement out of the function and here. So where this really is helpful is if you have a lot of functions, you can basically say only while vacant and, add this to a bunch of other functions. That's where you get the most benefit out of this. All right. So, you do get a benefit by cleaning up your code like this, but sometimes it can be a little hard to understand if you're having to look in multiple places. But if you have a lot of different functions that require this, this is how you reduce the duplication, which is nice. All right, so we can do this with the price check as well, and we can have a modifier that says costs. So we'll do it like this. Basically, we'll say modifier, and we'll say costs. And what we can do is also pass in an argument here. You say uint amount, and inside this function, we can basically move this inside of here. And let's see here. Say require message value. All right, it's greater than 2 ether. What we want to do is actually pass it in here. So uint amount require message values greater than or equal to 2 ether. We want to say amount here. All right. So let's see here. We want to move this here. Costs, and then pass in 2 ether. Yeah. All right. So now both of these checks will run before we execute this code. And we've moved the require statements out of this. Okay. All right. So the next thing that we want to do is, let's see here, talk about events. So events are pretty cool inside of Solidity. Basically, they allow external consumers to subscribe to them, all right, and find out that something happened in a smart contract. So basically, if you want to create a smart lock or something like that that actually unlocks a hotel room and listens to events on the blockchain or something like that, this is a good way to do it. So it could subscribe to an event inside this smart contract, and it will do things whenever this event is emitted. All right. So you can just create a new event like this. We'll say event occupy. All right. We'll say address occupant. This will be the person who opened it, occupant. And then we'll say the amount they paid, uint value. All right. So we'll say we can emit the event just like this. Say emit, occupy. Say msg.sender, msg.value. All right. So it's pretty simple. You just define the event like this, and then whenever the function's called, it will emit the occupy event. And you could subscribe to this, like I said, in a smart lock or something like that to actually open the hotel room. And let the person, or maybe dispense them a key or something like that, all right? So now there's one last thing I want to do before we test this out. We want to basically make this shorthand. So instead of having a named function called book, we want to create a special function in Solidity called receive, all right? And basically what this will do is create a function that will get triggered whenever you just pay this smart contract. So if you just simply, send Ethereum to this address, this is the function that will get called. So like if you open an Ethereum wallet like MetaMask, for example, I don't have MetaMask pulled up right now, but basically if you pay it, you just send Ethereum straight to this smart contract, then it will do this. Okay. So we'll say receive external. All right. You must call it external so that it can be called outside the smart contract. It's payable only while vacant and costs 2 ether. All right. So there you go. All right. So let's go ahead and compile this, test it out. Click compile. All right. So we got a problem here. Let's see here, modifier. Let's just update this. Let's get a problem with the enum here. Let's just try this. Let's try it again. All right, so we've got another problem here. Let's just check the modifier. I've got the code for this down in the description below, so if you want to actually check it with what I have on screen, you can just look at the GitHub gist. So let's fix the costs. I think I just have a small syntax error here. Sorry, everybody. Yeah, there you go. Okay, perfect. So like I said, I've got the correct code down in the description below if you want to make sure that yours is right before you do this step. Let's click compile. Next, let's deploy it. All right, so just click deploy. Let's go to the first address here. All right. So now we can check the owner like this. There we go. There's the owner. That's us. So now let's go to a different address and actually try to book the smart contract. I'll go to this one that has 100 Ether. And let's try to pay it. Basically, let's do this. Let's say value equals 1. Let's try to send it not enough Ether first. Basically, what you can do is do this low-level interaction. This will send Ethereum to the smart contract. So, we don't see a function name here called receive, right? That's because this is a special function in Solidity. This is how you interact with it. You send a transaction to the smart contract directly. All right, so click transact. Make sure you put in 1 Ether here, all right, to the value. Click transact. And boom, there you go. We got an error. That's what we expect. So we can expand this and see the error down here. Not enough Ether provided. Okay. Perfect. So now what we can do is, let's see here. We could do enough Ether. Click 2. And then transact. And there we go. It worked. It's green. Perfect. So let's try it again. Now that it's already booked, click transact again, and we should see an error. Yep, we do. Perfect. All right. This error is currently occupied. Perfect. All right. So that's our hotel room smart contract. We've demonstrated lots of concepts in this video. The status, the enums, the modifiers only while vacant, the costs, everything. There's so many concepts in this video, all right? We're going to cover a few different topics that deal with working with multiple smart contracts in Solidity, okay? We're going to talk about inheritance, factories, and then working with other smart contracts. And basically what I mean by that is like calling other smart contracts from inside of a different one, okay? Or interacting with smart contracts, maybe is a better way to say that. So smart contract interactions. All right, so let's get started. What we want to do is create a basic smart contract that handles a secret, all right? And so we'll start off building this inside of my contract. This is the basic smart contract we've been using throughout this tutorial series. So what this contract will do, will basically hold a secret value and allow a user to return the secret value. So we'll start off like this. We'll say string secret. All right. So we'll store the value inside of here, but notice this won't be public. All right. This won't give us a function that reads it. We'll create a special function for that, which will become clear why here in a second. Okay. So let's just create a way to get the secret. We'll say function get secret. And this will be public. View returns, let's see here, string, memory. And then we'll say return secret. Okay. So instead of making this public and getting this function for free, secret function for free, what we want to create a get secret function because we want to restrict who can call this function. And I'll show you how to do that here in a minute. All right. So the next thing I want to do is be able to set the secret, and we're going to do this whenever the smart contract is deployed. All right. So inside of the constructor function, we'll say constructor. We'll say string, memory, and secret, and then public. Okay. And then here we'll just set the secret like this. All right. So remember, the constructor function inside of Solidity is the function that gets called whenever the smart contract is deployed. It's run once and only once, and it's we create a constructor with this special constructor keyword. It's a function like other functions, but it doesn't get this function keyword with a name. It just uses a special keyword that tells it it's the constructor function. Okay. So that's the basic functionality that we want to implement, but we want to make this a little more sophisticated. All right. So right now, this get secret function, it basically can be called by anyone. So we want to create a modifier like this, where only the owner of the smart contract can call it. Okay. So I think I showed you the ownable pattern in a previous video. Don't worry about like skipping back to that video. I'll refresh you on it right now. So remember, we can create modifiers in Solidity like this. Let's say modifier only owner. Okay. And we can say require msg.sender equals owner. And if it fails, we can say must be owner. Okay. And then we run the function. And then we can put this modifier here. We'll just say public view only owner. All right. And then lastly, what we want to do is set the owner inside here. We want to say owner equals msg.sender. All right, so really quickly, let me just refresh you on what's going on here. So this is a modifier in Solidity, which basically is something we can add to our functions that will get called before this code in the function runs. Like basically, we could just put this here. We could just say, require msg.sender equals owner. All right, must be owner. But it's better to do this inside of a modifier. Well, a lot of times it's common to do it inside of a modifier, and it can be advantageous, especially if you do this kind of thing in multiple functions. All right, let's say like you have multiple functions that could only be called by the owner. You don't want to repeat this line every time. So it reduces duplication to put it inside a modifier like this, and you can just add it to every function that wants to be restricted to who can call it. All right. So we set the owner in the constructor function like this. We just say owner, which we need to store here. Say owner. All right. Address owner equals msg.sender. This is the address that deployed the smart contract. Okay. And then only this person will be able to read the secret. All right. So if I switch to a different account inside of Remix, then they won't be able to call this function, right? It'll throw an exception. So this is really common in Solidity to have an ownership model where someone owns the contract and you restrict what the owner can and can't do. And for that reason, it's really common to use a library. And a lot of times libraries in Solidity are just, there are other smart contracts that can be reused. So you don't want to reinvent the wheel every time you want to restrict the ownership on a smart contract. So a lot of times you'll have a separate smart contract called like ownable or something like that you import into your project, and you create a smart contract that inherits from it, right? So that's one way to work with multiple smart contracts, is to use inheritance, to use libraries, all right? So I'm going to show you how to do that right now. So what you'll do is create a separate contract like this, a contract ownable, and we'll move a lot of the logic related to the ownership into the ownable contract. So we'll put the owner there. Okay, oops, sorry. Put it here. And then we'll put the modifier in there as well. Oops, sorry. There we go. And then what we'll also do is add this line inside of there. But here's where it gets tricky, okay? We have to create a constructor inside the ownable contract, okay? But we don't want to run both these lines. All we want to do is run this line, okay? And we don't want to accept a secret argument because we don't need that in here. So how do we tell, how do we call this line inside of this contract? Well, we say super, All right. So super, what it does is it calls the constructor of the smart contract that it inherits from, like this constructor function, and you can call super in specific places. So, it doesn't really matter in this case. We could call super here, but sometimes the order does matter, and it's nice to be able to call super in an explicit place. Okay. So the last thing we need to do is say we need to actually inherit. So we'll say is ownable. All right, and that allows the smart contract to just inherit from ownable like this. All right. So now all of the ownership logic has been abstracted away into a separate smart contract, and we can just pull it into this one. And yeah, that's how it works. Basically, we could have multiple functions that are, we restrict who can call it based on the ownership. We could have multiple smart contracts that, inherit from this ownable pattern. It really drives things up and makes it really nice. And this is a very common pattern in Solidity that you need to know if you want to become a blockchain developer. Okay. So the last thing I want to show you before we compile this and test it out is how to call smart contracts from other smart contracts. All right. And then how to also create new smart contracts inside of a smart contract. Okay. So we'll do this in the same, with the same thing. Essentially what we'll do is we'll move all of this, secret storage into a separate contract. Okay. We'll call this secret vault. Say contract secret vault. All right. And we'll, store the secret inside of there. Okay. And then we'll also, let's see here. We'll return the secret. So this thing can have a constructor too. We'll just move this constructor inside there essentially. All right. Oops, sorry. All right. We won't do super because it's not ownable, right? And then we'll move this get secret function inside of there. Okay. And we'll move the ownership here. Okay. So we've moved all the get secret and all the secret behavior into the secret vault. Okay. So now what we want to do is basically make this contract sort of a proxy for the secret vault. And this is called a factory pattern, basically where a contract will create another smart contract. And I guess really a factory is a case where a smart contract will create multiple new smart contracts. In this case, it's just going to create one. So it's not a true factory. Like a real factory would create multiple secret vaults and store all of them. And like you could reference each of them. So it's not really a factory, but what it does is it's going to allow us to create a new smart contract and fetch the value from it. It's sort of like a proxy. It's honestly probably not the best demonstration of this, but I think you'll get the idea. And you could research other ways on how you might use something like this, but this is definitely something that is worth understanding in Solidity. Okay. So what we'll do here is accept this secret, and we'll say, we'll create a new secret. First of all, we need a place to store the address. So address secret vault. Oops, vault. Okay. And then like this, we'll say secret vault. I'm gonna scroll up here. All right. Secret vault. Oops. Equals new secret vault, and then pass in the secret. So this is how you instantiate it. Basically, secret vault, the constructor accepts one argument, which is the secret, which we'll create here, and we'll just pass it down whenever we create the new one. So new secret vault, pass in the secret. And then basically we'll create an instance of this like this and assign it to this underscore secret vault variable. And then we'll store the secret like this. We'll say vault address. All right, secret vault. All right, secret. All right, perfect. And then say super. Okay. And then that will create the new secret vault with the secret in it. And now the owner will be the only person that will be able to get the secret. And so we can call another function from a different smart contract like this. We'll say secret vault, equals underscore secret vault, capital secret vault, and then pass in secret vault address. All right. So whenever you fetch the smart contract, basically you give it the contract interface, you pass in the address that tells you where it is on the blockchain, and you assign a new variable, like this. Okay, it's of secret vault type, and then we can say return a secret vault get secret. Okay, all right, so let's see if we can compile that. There may be some errors here. All right, let's just change this, refactor this. All right, perfect. There we go. So let's compile it. All right, there we go. Forgot to call super there too. All right. There we go. All right, so let's compile it, and then let's deploy it. So let's kill this old one. All right, remix. Here we go. So let's put the secret here. We'll say foobar. Okay, click deploy. My contract. We'll try to see the owner. All right, the owner is our current address, right? That's what we deployed it with. And then we'll try to get the secret. Foobar. Awesome. So now let's change to a different account here. And we'll say get secret. And if we look at our transaction log here, or our log here, we'll see that it reverted. So we'll try it again. And there you can see it. All right. So that's how you work with multiple smart contracts inside Solidity. That's how you use inheritance. That's how you create new smart contracts inside of a smart contract. And that's how you call other smart contract functions inside of a smart contract as well. All right. So I hope you like this video. This is definitely stuff that you need to know if you want to become a blockchain developer. All right. So, if you haven't already, go ahead and subscribe to the channel, click the like button down below. And if you want to take that next step and master blockchain step by step from start to finish, then I can show you how to do exactly that. Okay, just head on over to dappuniversity.com/bootcamp to get started. All right, until next time, thanks for watching Dapp University.